Okay, 2012 AMC. This is problem 18 from the AMC12B and problem 22 from the AMC10B, and it's a really cool problem. It involves a lot of cool little things. So it says let A1, A2, all the way up to A10 be a list of the first 10 positive integers such that for each 2 less than or equal to I less than or equal to 10, either A sub I plus 1 or A sub I minus 1, or both. That actually doesn't even matter. I'm just going to cross it off. You can't get both. Appears somewhere before A sub I on the list. How many such lists are there? Okay, here's the idea. So we have the first 10 integers, and apparently, it doesn't really say it strictly in here, but I'm going to say they cannot be repeated. So what's going to happen is this. For each step, so let's just say for a little example to illustrate what's going to happen here, if I started my list off with the number 3, then afterwards I could either go up to 4 or down to 2, because if I go up to 4, then my term minus 1's on there. If I go down to 2, my term plus 1's on there, but I can't choose any other throughout here. Let's just say I put in 4. Okay. The next choice I have is to put in 5, go up to 5, or down to 2, because 5 is 1 bigger than 4, and 2 is 1 less than 3. Okay, so it's going to go through this. But that is not the way. I'm not going to multiply by 2 a bunch of times. That's going to be a dead end. It's going to cause nothing but grief. So, but this just gives you an idea. So you can either do 4 or 2, and then you fill this out. Okay, so what I'm going to do, though, is say for any A sub 1, there will be, let me make sure I've gotten this correctly, there will be 9 choose A sub 1 ways. Okay, I'm going to just a terrible notation, don't do this. But 9 choose A sub 1 ways to get it to decrease down to the first term. So what that means is if I have a 3 here, okay, is this what I want to say? No. 9 sub A sub 1 minus 1. That's what I want to say. So if this is a 3 here, I need to have in 2 locations in this list of 9 remaining things, 9 choose A sub 1 minus 1, I need to go down by 1 to get the 2 and the 1 in there. And everyone else I'll step up by 1. So this alone counts how many ways I can make a list given any starting value. And we can, if we really see, we can jump to the answer, but I'm going to do this, okay? So if, let's say, A sub 1, and then we'll count up how many ways that can happen. So A sub 1, if A sub 1 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay? And if I put this in, so there will be 9 choose 0 ways to get a 1 in the front, so that'll be equal to 1. There will be 9 choose 1 ways to get a 2 in the front, because I have to have 1 decreasing out of the 9 remaining. That's 9 possibilities. 9 choose 2, and that's going to, let's see, 9 times 8 divided by 2 gives me 36, I believe. Alright, all the way down to 9 choose 9 equals 1. And I'm going to add all these up. Now, if you love calculating NCR and you're somehow quicker than I am at that, that's great, but there's a nice formula. This can all be based on the binomial theorem that says the following. So, as I said, really cool problem. So, if I had x plus 1 to the, let's do the 9th power, this will equal x to the 9th, oh sorry, let me do this correctly, let me make sure I got this all right. It's going to be Now 9 choose 0, 0 ones, x to the 9th, plus 9 choose 1, 1 1, x to the 8th, plus 9 choose 2, x to the 7th, so I've chosen 2 1s and 7 x's, plus all the way down to 9 choose 9 1s. And the magic happens in what happens when I make let x equal 1. And that's just going to say, okay, I'll have 1 plus 1 to the 9th, which in some essence is going to be 9 choose 0 times 1 to the 9th, plus 9 choose 1 times 1 to the 8th. Okay, and 1 to the 9th is 1, 1 to the 8th is 1, da 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 da, 9 choose 9. So this will add up all of these for me, but 1 plus 1 to the 9th is just 2 to the 9th, which we all know is 512. So that's our answer. And you'll get the same thing if you work this all out. That would just take you far longer than this problem, which already takes a little time to get all this stuff running.